Thanks for having me here today. Yes, today we're going to talk about minimum viable migrations, a framework for cloud modernization, and of course, how Python fits into that. And sorry for the last minute change to the program, some issues with the other talk. But in any case, I'm very happy to talk through how we can modernize using minimum viable migrations in Python. Now, as I mentioned, my name's Ben. I'm the founder of a company called Alios, which is a digital consultancy helping people to adopt serverless. I'm also an AWS serverless hero, and as you can probably tell already, I say serverless quite a lot. I'm the editor of the Service Transformation blog, podcast, and newsletter, and run a few open source projects in that space. So feel free to check out the Service Transformation Medium if you want to find any of those articles, and also the alias.com website has links to the open source projects. Enough about me, though. Let's chat through what we're going to talk about today. So today we're going to talk about what modern cloud looks like with serverless and Python. We're then going to talk briefly about Agile and MVP. I'm sure you already are all quite familiar with that topic, but we're just going to run through it to remind ourselves of the concepts. Then we're going to look back at what cloud migration and modernization typically looks like and contrast that a bit with what Agile principles typically look like. And then talk about maybe a different way of doing it using minimum viable migrations and event-driven architectures to modernize cloud applications and how we bring our team along on that journey. Now, serverless is probably a term many of you already know, but it's also one of those terms that means different things to different people. To me, serverless is an architectural movement that allows us to build and run applications without thinking about the underlying servers. Developers can write very sort of clean and logical application code, and they don't really care where it's run. It's isolated and abstracted away from them. Typically, also, we make use of third parties for things like backend logic and state, things like Cognito and AWS for user account management, to also further offload what we're building. So we focus more on the custom code that represents our business logic. There's also a framework with the same name, the Serverless framework. It's a really great infrastructure as code solution, but it also makes talking about serverless a little bit complicated. Today, we're going to be talking about serverless, the architectural movement, rather than serverless, the framework. And why do people adopt serverless? Well, primarily there's a cost reduction, not just in the cost of running your application, but also the total cost of ownership of build, running, and maintaining your application. There's not no ops, but there are definitely less operations work needed in terms of running and scaling these applications because so much is abstracted. Developers can focus on delivering business value rather than focusing on managing the infrastructure. And these applications are scalable from day one. And as we start to make greater usage or greater utilization of server resources inside of data centers, they also have the potential to make our applications greener as we share resources more and more through finer granularity. It's not just Lambda, which is the functions of service from AWS. It's also things like S3 for storage, DynamoDB as a completely serverless NoSQL database, API gateway for routing requests into an event-driven serverless application, Cognito for user authentication, SQS for queues, step functions for workflows, Event Bridge to build an event bus in a completely serverless way, and many more services. And it's not just on AWS, other cloud providers also support serverless, but Lambda is probably the poster child for serverless, the one you will have heard the most about, but the others are extremely important in how we build out these applications as well. On the subject of Lambda, Lambda can run almost any runtime. In fact, you can provide a Bootstrap or a Lambda layer and run any runtime you want. But obviously today, we're going to be talking about running Python on Lambda and how we can build cloud architectures and migrate to them. So Lambda supports Python 3.9 down to 2.7. Hopefully we're on more the 3.9 than the 2.7, but it can be useful that it supports a range, because that means as new versions come out, your code still runs, but you are prompted to upgrade your code as time goes by. And you can bring a Lambda layer to run any version of any language that you want. So you do have the flexibility to run other versions if needed. A Lambda function is quite simple. It's composed of a handler function of code, which will return a value. It takes an event and a context, and that event body can be a dict, a list, a string, an int, or a float, or a non-type. And then you return a value that goes back to whatever triggered that Lambda function. Typically return an object, but you could return true, false, or a number. It can really be as extensive as you want it to be. The real question there is what triggers that Lambda function? So what is that response going to? And it's actually quite a huge range of services inside of AWS that can trigger a Lambda function. It could be an Alexa skill. It could be a DynamoDB stream when data's changed. It could be API gateway, building out a REST API or a WebSocket communication with an application. It could be AppSync triggering via GraphQL. It could be Cognito after a user's authenticated or being created. It could be a Kinesis stream. There are many, many ways to trigger Lambda functions, which means we can build really nice event-driven architectures, but sometimes we need to make sure we put some guardrails around how we build them so that they remain clean and don't get a bit tangled together. As you can see, serverless microservices basically take those services and use them. There's a lot of Lambda in this example. For instance, we have several Lambdas calling a DynamoDB, providing a microservice, as well as another that has S3 Lambda and step functions providing a different microservice functionality. And typically, the best practice for building these out is to do it in an event-driven way. So rather than synchronous requests between those microservices, we can leverage something like AWS Event Bridge to have completely asynchronous event-driven communication, which has a lot of advantages of loose coupling and other advantages we'll talk about a bit later. But that's sort of the architecture we'd like to get to, completely greenfield. Let's go and build that. Sounds great. But obviously not all of us are in a completely greenfield environment. So how do we get from our system as is, potentially a legacy system that's on-premise or something that's been lifted and shifted, and how do we get through to an architecture that looks like this? And we're going to come on to how to do that with MVMs, and it doesn't just apply to serverless, it can apply to modernizing a language, modernizing the structure, changing the environment in which something's being run. But before we get on to the definition of MVMs and that approach, I think it's good just to remind ourselves of agile principles and what an MVP is in that space. Now, I'm sure lots of you have seen this diagram before many times, but two approaches to build something, one that's functional from day one where you can get feedback, one that waits till everything is built before you get feedback. And obviously there's many advantages to an MVP approach, and many people take an agile approach and use MVPs these days. In terms of what agile is, there's many conflicting definitions. Typically it's viewed as a software development. In software development, it's a set of agile practice. It's a set of practices that are about discovering requirements and developing solutions through collaborative effort across functional teams and involving customer end needs. Now, I don't know about you, but if you've been involved in many migration projects, they typically aren't about discovering requirements. There's typically less collaborative effort. It's not always about cross-functional teams. And customers and end users are very rarely involved. Minimum viable products often come alongside with Agile, and they really focus on releasing something that with just enough features to be usable by early customers to get feedback, which has huge advantages in the sort of build, measure, learn cycle where we build something, a new app to order coffee, let's say. We measure how people use it, we learn from that and we iterate, rather than investing loads of time in building something we think people want, but haven't validated the product or the technical assumptions in building it. Now, this allows us to test hypotheses earlier, it allows us to learn faster, it reduces waste in what we're building, it allows us to get something to users quicker, and also allows us to validate the assumptions both in the product and the technology. But very few of those principles are often taken in a cloud migration project. We're not typically testing things early. We don't typically learn fast. I've seen a huge amount of waste in migration projects, and we're rarely shipping to customers quickly because people get locked in a very big bang release rather than taking small slices like an MVP, even a greenfield product. They instead try and build the whole thing. It's maybe taken 20 years to build, and obviously isn't going to happen very quickly. Before we jump in a little bit more to that, I think it's good just to think about what migration means in terms of cloud migration and modernization. Cloud migration is that process of moving a company's digital assets and operations from one cloud provider to another. It could be from on-premise to cloud, or from one cloud provider to another one. And application migration, not always related to cloud, is the process of moving an individual application into a different environment. And when we think about cloud migration of an application, we often think of the 4 or 5R model of rehost, so lift and shift to move something from one place to another without any changes to the actual application, refactor to reuse some code but change some of the interface with the underlying infrastructure, to rebuild, so just completely re-architect from scratch with maybe the best practices of event-driven serverless cloud architecture, rather than just try and containerize something and move it across. And finally, replace, to discard and maybe buy rather than build something instead of trying to migrate an application. And migration, if we just take it back away from cloud for a second, is really a move from one domain to another. We have an application domain A, we want to move it to the domain B. That could be from on-premise to cloud. It could be from .NET to Python, probably a migration many people might enjoy. Or it could be from a monolithic application to a microservice application, so a real structural migration, or a cloud migration from maybe not even on-premise, but from a lift and shifted application in the cloud through to a fully cloud-native serverless application, refactor migration to leverage the full power of a particular cloud provider, in this case, AWS. And this is where I started to work on many projects, migrating people to cloud, or migrating people to serverless, or migrating people from one language, for instance, to Python, or between different domains. And I often saw people making the same mistakes of a very big bang approach of let's rebuild everything and then release. And then typically midway through, people hadn't got very far. And then either the project got canceled or a big pivot was taken. Instead of doing that, if people take very small slices of an application in the spirit of Agile and MVP, we can actually learn a lot faster and have lots of the other advantages of Agile, even though it's a migration project. So if we go back to that shift of domains, let's say from a system as is, from a system to that could be from on-premise to cloud, cloud to cloud, language to language. We need to move from domain A to domain B, the as is from the to be to the to be. Now, in a waterfall approach, we'd have to gather requirements, design, implement, and then only once everything is done, do we then go in and verify what we've built. And the real issue here is the deadlock of feature paralysis. Let's say the system has SSO, CRM integrations, email sendings, a core feature, a legacy feature that's maybe not used so much anymore, a load of other features. It's basically a matrix. Until we get ones in the column for to be, we're never going to redirect users to be able to shut off any part of our old system. And this causes a real deadlock because getting ones in every column means we have to rebuild all of those features and functionalities in the new technology or the new cloud or in whatever new domain we're going to. And in the case of cloud migration, let's say from an on-premise to a fully serverless event-driven architecture, something I'm actually doing right now for a large airline, that'd be a huge amount of work and it'd be years of time until you actually get to switch off the old one, switch on the new one. And by that time, you've probably made a lot of assumptions that are incorrect, and also the market and the product have probably changed quite a bit. So this is that deadlock of feature paralysis. Now, potentially there are some low priority features, things like legacy features that we decide, okay, as a product, we don't need this anymore. It's a least significant bit in this matrix, but basically we can decide not to rebuild that feature and maybe we can go live. And that's low priority features. We can maybe have an opt-in beta program for the new system where you don't have all the features, but you have most of the core features and that's enough. We could remove those high cost, low reward features, or we could choose to migrate most of our users to the new system and they'll get all the benefits of the new technology. But maybe there are some older customers who need this very legacy SAML integration, whatever it might be. And therefore, we're going to leave them running on a much smaller version, but in the old domain. But there are going to be high priority features. So this is a small tweak we can make to maybe get thing out a few months earlier. But what about those high priority features where there's loads of them? We're still going to have a very long time period of them, a very big bang release. Well, if we do have high priority features, we kind of need a strategy to run two systems in parallel. And it's very important that the way we run them in parallel, we don't negatively impact the design of the new system with the constraints of the old system. I'm a big advocate of domain-driven design, things like event storming or event bridge storming, which is an extension I've built on top of event storming to model around an event bridge-driven architecture. But when you do domain-driven design, you don't want to look back at a version of the system we've built and recreate that way of building it. You want to look back at the actual, the domain, the real world system that you're trying to build, and then try and model the perfect domain for that. And it's very likely with a legacy system, it was built based off one domain model. A lot of stuff has changed. It's still based off that original domain model, and that's not fit for purpose anymore. So one important thing is that when we're designing a new system, and we're going to run that in parallel, so there's going to be interaction between the old system and the new system, we need to make sure we don't negatively impact the design of the new system with the constraints of the old system. The other thing we also need is an exit strategy where we can actually turn off the old system. And this eliminates a lot of the complexity of running two systems in parallel. When we add a new feature, do we have to add it to both things in parallel? When we fix a bug, is it in both places? Running two systems is great in one sense because we can get live earlier, but also it's going to be double your infrastructure costs potentially. And there's two things to maintain. That's a lot of cognitive load and a lot of skills you have to duplicate within a team. So this is taking those principles of running in parallel and releasing earlier. This is where I got to sort of a framework that I've used with multiple companies to migrate them from on-premise to serverless, from a lift and shifted to serverless, from one sort of domain model to an improved domain model. And it's what I call minimum viable migrations, but it's a usable migrated version of an application from one domain or paradigm to another with a subset of features to be used by some or all customers. Much like an MVP, we were able to release this to production, validate assumptions, both on the business and the tech side, and we're able to move real users with it. It's not just beta users, it's not just internal users, it's real users being migrated, preferably all of them, but if not, a subset of them. And why do we do it? Well, for much of the same reasons as an MVP. We can learn faster, we can test assumptions earlier, we can focus a team on a culture of continuous delivery to production. And I think that's one of the things that migration projects often struggle with is if you're not shipping to production regularly, teams get demotivated. There's something, and there's a great focus and attention to detail and great engineering practices that comes from releasing to production. So having a culture of releasing to production very early in a migration project helps instill a lot of focus and also a lot of rigor in what we're doing. And finally, we can deliver to customers faster. If we're moving to a new technology, it's likely because it brings greater agility or allows us to do things we've not been able to do before. If we're migrating to that new technology, even if it's just 50% of the application that's been migrated, if it's with the real users and being run in parallel, then we can actually realize the return on investment that comes from being able to leverage that new technology, even if it's just in parts of the application. So moving back to that example of moving from a domain as is to a domain to be, the color coding here isn't very great on the screen, but so we have an app with a number of features. Let's say there's 4 of them, color coded, as you can see on the screen. We haven't yet built them in the to be. We need to have some features running in the as is and some features running in the to be. And as you can imagine, a bi-directional channel of communication between those two systems. And this is where event-driven architectures become really useful. When we build modern state-of-the-art serverless cloud applications, typically they're event-driven. Lambdas are very natively triggered by events, but also event-driven architectures provide a lot of loose coupling. They enable teams to deploy independently. They make testing simpler. They reduce the cognitive load of developing within a particular service. They really try and mitigate building that big ball of mud of synchronous request responses, that big web of interconnected microservices, and it simplifies a lot. But not only that, it also potentially creates a vector for us to have events moving between the system as is and the system to be. If we rethink that as is to be scenario, we can go from not the Big Bang release to a series of MVMs, a stepping stone path to migrate everything. And that means we need to run the system in parallel, so both in the new technology and the old technology, and have a bi-directional channel of communication. And that bi-directional channel of communication is of events. So if we're using AWS in a serverless architecture, we might use something like Amazon Event Bridge, or you could use something like Kinesis potentially, or Kafka. But having an event system, and in serverless and AWS, let's say Event Bridge, means that our new architecture, let's say we do domain-driven design, we do a lot of event storming, can be really nicely defined with very separated bounded contexts and services that are deployed independently. And events are the primary way those services communicate. If we extend that event bridge to move between, let's say, on-premise to in the cloud, or between 2 different cloud providers, or between 2 applications running in different technology but hosted in the same place, that means that then we can get the old system to trigger events of the new system. And it's very important we don't impact, again, the design of the new system with the modeling and constraints of the old system. If we can have a way for the new system to trigger an event, let's say the user service hasn't been migrated yet, and we want to have the new system know when a new user has registered because the marketing service has been migrated and that sends an email. We want the legacy system to generate an event that matches the contract of the new system. And then that will go into the event bus of the new system. The marketing service can then react to that event as it's been built to do, whether that event comes from the new system or the old system, and the email can then be sent. But it also has to be bidirectional because, for instance, let's say we want the payment service, which let's say has not been migrated, to know whenever an order has been placed, but that has been migrated, we'll then have to go the other way and send an event from the new system to the old system. But the important part here is the new system has to generate that event matching the contract of the new system, and we need some sort of translation layer between the new system and the old system. Now, domain-driven design has a useful construct of anti-corruption layers, which are quite useful and have sort of a model for building a facade over a system and having that sort of translation feature. But in a very basic sense, we just want to trigger that event, and then it's a job of a small translation layer between the 2 services to make it match either the event structure of the old system, if it was luckily event-driven, but probably to then go and make a synchronous request response into the old system to go and make the change that's been envisioned. Now, there's obviously an investment in building this cross-cutting event bridge and having that translation layer, but the return on investment of getting live faster and validating assumptions faster is definitely worth it from my experience, and all the other advantages we just talked about. And using something like Amazon Event Bridge, it's actually very easy to have an event bus open and to add a very simple API for a legacy system to be able to then go and trigger events in the new system. So to start with MVMs, the list of requirements is to have that defined list of events and the schema for those events from the business domain. Event storming is great to look at from domain-driven design. I've got a blog article on event bridge storming, which is a very similar concept, but applying it specifically to serverless event-driven architectures. But basically taking a step back, not just recreating what we already have in terms of the structure of an application, looking at the real world system we're trying to build, and then modeling the perfect events for the current version of that system. We can then go build our event-driven architecture around that, and then use that as a contract for that integration layer we just talked about. We're going to need an event bus in the new system. We're building in an event-driven way. And we also need the ability to emit events from the old system into the new system, and an ability to react to events from the new system in the old system. The advantages, as I talked about briefly, are we can go live faster. We can iteratively build up feature parity. So we no longer have that deadlock of feature parity, or that paralysis of feature parity. We can learn faster because we're releasing, and to be honest, I never really trust a system until we get it to production with real users. We can test assumptions faster, be them business assumptions on cost being reduced by the new technology, or assumptions that particular parts of that technology are going to interface well. And the new system team don't need to be experts in the previous technology, so we can have a team working in the new technology without having to think about all the implications of the legacy system. But of course, the change management of that and making sure we bring people along on that journey is extremely important. So making sure you enable people maybe from the legacy system to be onboarded into the new technology is super important. But when you make a new hire, potentially a junior developer or a mid-level developer, they don't have to go and learn the legacy system before they can actually go and add value. They can be dropped directly into the services that have already been migrated into the new world, and then they can go and work on those independently of the constraints of the legacy system. There are definitely challenges. Data duplication, especially as, yes, our new system may be eventually consistent, but the old system probably wasn't built with that in mind. GDPR, we're moving data between different environments, and we're also replicating data that then has to go be cleaned up. That can often be a constraint. GDPR, by the way, is a privacy regulation in Europe. I'm not sure it reaches the US, but I'm sure there's a very similar concept there. Networking between systems, if it's from on-premise to a cloud-based system, how are we doing that networking? Do we have to go through some sort of VPN? How do we integrate directly or go between two cloud providers, maybe from AWS to Azure or Azure to AWS? They don't have the same event-based system. So do we use a third-party solution? Trigger Mesh is actually trying to solve that problem, worth looking up if you've not seen it before. Or do we have to add some sort of abstraction layer over our event system? And then finding that mechanism to trigger events from the old system and the new system. That could be through change data capture, through log capture, direct integration with database triggers, through manually changing the previous system's application code to go and trigger events as a side effect. There's many different ways to do it. The easiest one is automatic, but we're doing that translation layer from the old way of data modeling and the old systems, maybe not event structure, but payload structure into the event structure of the new system. In conclusion, from my experience and the teams I've seen using them, MVMs allow us to release faster, to test assumptions faster, learn and deliver value faster. They're kind of stepping stones to that final system. And an event-driven architecture allows a very clean bidirectional interface between systems. And as most modern cloud-based architectures are becoming event-driven, it's very natural to leverage that as a natural advantage of the new paradigm in providing us a way to sort of have that stepping stone approach of minimum viable migrations. And before we come on to questions in just a second, I think the spoiler here is I've said that MVMs are those iterative stepping stones to a final system. There is really no final system. As you probably all know, technology keeps changing, things keep changing, requirements keep changing. So if we do have a fully event-driven architecture, when there's the next paradigm, maybe it's something, some new technology in the cloud, maybe it's a new language, maybe it's a new framework, maybe it's a new capability. If we're already working in terms of events, the next migration becomes a lot easier because we already have the event-based system. So migrating over to a new paradigm becomes a lot more trivial than it would have been in that initial migration where we first set up that channel of communication for the minimum viable migration. So keep iterating on your MVM is probably the main message at the end of that. As I mentioned, I run the service transformation blog. I've written quite a detailed blog article and sort of the methodology around that. So feel free to take a look. I think there are some Python examples in there as well. The slides you can find at slides.com/Ben Ellerby. So you can look through all of the slides and use them at your leisure. And some of the open source projects that I'm using as part of this process, you can find on the Alios website. That's alios, ALEIOS.com. And you can also follow me on Twitter where I share a lot of the stuff I'm doing. That's at Ellerby Ben.